Hello, in this lecture we are going to see analysis of quicksort. First we'll try to understand what is quicksort, how it is going to perform, and then we'll try to find what is the recurrence relation and all. So quicksort, I will have A of n, that array. I will have an array. In that array, I have to select a pivot element. After that pivot element, I will have I and j value. So I have to compare all the time I and j value and compare with the pivot element. Wherever it is going to lesser than the pivot element, I am going to just keep it as. If that is the maximum value, then I am going to swap the values. This I have to perform for one time. After that, my pivot element is going to set at some middle place. Once it is going to set in a pivot element at a middle place, once again I will have two parts. This is the first part and this is the second part. Once again I have to start continuously till the sorted array. I will get A of n. So I will start with A of n, which is unsorted array. I will perform the activities and I will get A of n with a sorted array. As we know that both are the divide and conquer method. The quicksort is nothing but divide and conquer method. So we are going to analyze the how T of n is going to occur. So T of n equal to, as we know that 2t n by 2 plus n. Why 2t n by 2? As we know that pivot element is going to select, then it is going to set at some center place, then it is going to divide into two parts. So this procedure is going to continue till to find my final answer. So that how 2t n by 2 comes? The first part n by 2, this is t of n by 2 plus second part n by 2 plus the n number which I have to cover in a unsorted array, and the final answer is also A of n in a sorted array. So f of n will be n. So that t of n equal to 2t n by 2 plus n. This is recurrence relation for quicksort. Now we'll try to do the analysis and find the complexity. When we will compare with our master theorem, T of n equal to at n by b plus f of n, the a value equal to 2, b value equal to 2 and f of n equal to n. The first step of master theorem, I have to find out n to the power log a by b, n to the power log 2 by 2 equal to n to the power 1. The step number 2, n to the power log a by b I have to compare with f of n. In a given problem statement, I find out that n to the power log a by is nothing but n to the power 1. And f of n in a given recurrence relation or the recurrence relation of quicksort, that is n to the power 1. When we equate left side to the right side, I found that both are equal. When both are equal, then epsilon equal to 0. When epsilon equal to 0, I have to use by master theorem, case number 2. By master theorem case number 2, I can say that T of n equal to n to the power log a by b into log n. So n to the power log a by b, here is n to the power 1 into log n. That is n into log n. When I will write in a final answer, T of n equal to big O of n into log n. This is complexity of quicksort. Now the all three condition, when it is in best case, when it is in average case, when it is in worst case. In best case, that will be O of n log n. Why? Even that is the best case. I have to take a pivot element, I have to divide into two parts. Once again the pivot element is going to generate, check till the sorted array. So when it is in a best case, I have to perform all the activities. When it is in a worst case, I have to perform all the activities, that is O of n log n. Now in worst case, the scenario is that if the given array is a sorted array but it is in descending order, then I have to check the pivot element up to n into n times. The pivot element into n times. So that worst case is O of n square. Worst case is O of n square. If we check the complexity, for best case it's O of n log n. In average case it's O of n log n. In worst case it's O of n square. Now as we compare the analysis part in a quick sort, keep in mind the best case and average case require the same time, the same O of n log n, and in the worst case it's n square. This is all about the analysis of quick sort and the complexity of quick sort. Thank you for the listening.